I do.
Yeah.
It's quite weird.
I don't know if they have like
But you bring to the other one.
No,
like
I see. What is it?
yeah, but like my friend was very worried because like actually like one of
But I actually never seen
and
I have it.
like 1 week ago.
Glazed chicken, so like.
Tomorrow is the
First skillless
job.
so then I was just like perhaps
What
we
is the
should
job?
I want to learn.
Yeah, let's do it. I'm down with it. Just thinking, you mean you're doing like a whole job or stuff.
What's the double the two parts are going the summer?
Yeah, I'm doing to spend money.
Spend that for Madrid.
In Saddle. No,
I actually like to comment that about like
that was kind of bad. It's really for a walk. Like I actually cooked those. No. That's what I've never.
I
I mean, I did it when I came here like years ago, but
It's like
very good. Like she went up.
it's like I don't remember the names of things.
Was everything going?
Interesting. I would say that Friday was just nice,
waking up like a dog. It was
Oh my god.
Did you know what people say? It was the. Yeah, it was mostly. It was. Really? Us. And Kanishka.
Are you free?
Oh, I just.
yeah, I'm pricing. I don't know. I maybe catch up.
I did not plan it. I did not plan it.
I think it was stay.
Can you have English?
That was the
So
quick
why are
like
they
that.
only those pictures? I saw them. Like this is how Julian feels when I send him his pictures. Like I experienced that kind of embarrassment. Some sort of way when you see like your photos of you being drunk on the
Like, it was super nice.
basically.
I like that. Yeah.
I have more compassion towards you. I mean, I just went to the pub. I didn't go out. We went to the sleep. I had a party going in my house. My brother and his friends were like 5.
that fun?
I hung out for a bit. They ordered pizza, so I had my own shit. Because I was with them until like 10:30. They knew and then my brother had a party going on. Like, what are you? And also, like, I would not the only sober person who was like high on because you would want like a funny it's genuinely like also like, I was so tired. I came home at like 6 a.m. with all of this. I don't have it. But she's like
Yes.
Jersey recovered from Berlin.
I heard those. Twice the.
No, we have some.
No, I'm tired of FOMO. I wish I had.
Let's do some chicken.
In the summer.
Just play Strada di fare brava in qualche stagione.
Hi, let's talk.
I hope you're all well. So today we're entering week 10. This is GY426, and today we're going to talk about international environmental agreements. So this is going to be slightly more technical than what we saw last week, but it's going to allow us to answer a challenging question, that is, how can we enforce international cooperation? Why are environmental agreements difficult to negotiate? And I think that this is really crucial to understand, especially given the geopolitical context. So please don't hesitate if you have questions. You're going to see that we are going to start by deriving, so we'll start with the prisoner's dilemma that you probably all know, but so I'm going to go fast. But still, I think that it's a useful reminder. Then we'll turn to solving a model of enforcement, and we'll discuss an empirical paper written by my colleague Eugénie Dubois. So, the big questions for today are: why are environmental agreements so difficult to negotiate? So as you probably know, it's not easy to enforce these agreements. Most countries, they are not willing to cooperate. The countries who sometimes enter the agreements, they're also quite small, so they don't really, we don't see enough change in terms of reduction in emissions. We are also going to discuss one of the rare cases of the successful international environmental agreement that helped to solve the problem of the ozone layer. And finally, we'll try to discuss why can't we solve, or why aren't we solving climate change in light of the theories we're going to discuss today. So the learning outcomes are going to be to use game theory to model international environmental agreements. I'm not going to derive all the models, but on Moodle there are the mathematical solutions if you're interested and you want to do the work at home. We'll discuss mechanisms of self-enforcement and contrast ozone and climate, understanding the differences and the similarities. So let's start with some motivation first. So international environmental agreements, what are they? They are treaties between countries to collectively manage shared transboundaries environmental issues like climate change, pollution, or biodiversity loss by setting common goals, trying to establish rules, and creating framework for both cooperation and accountability. So the oldest international environmental agreements, they date from the 70s, and today there's a lot. There are a lot of those agreements that exist. We are not actually aware of most of them, but there are about 4,000 different agreements that exist. And if that's something that interests you, there's actually a data set that explain what they are, their particularities, etc., etc. And they cover many topics such as agriculture, water resources, pollution, trade, energy. But most of those agreements, they are happening at a relatively small level. So they can be bilateral or multilateral. And multilateral agreements, they cover 1,500 agreements, so it's not that small. But most of the treaties, they happen at a relatively small scale. So quite often regional in scope. And a lot of them also concern sea and water resources. So, as you probably know, in economics, we tend to consider having a stable climate as a global public good. and we are going to see pollution in that context by symmetry as a public bad. So everything that's contributing to the instability of the climate, so climate change basically is going to be seen as a public bad. And here what you can see, and if you're taking this class, you're probably very much convinced already that climate change is taking place and that the consequences are more and more clear and visible in the data. This is just to further motivate this, and we have this economist from the University of Reading, where that has computed the global temperature change relative to the average between 1961 and 2010, and we see that progressively before temperatures were quite below average, and now they are starting to increase, and so the mean is changing over time. So that's what we're seeing, just to motivate this idea of a global climate being a stable climate being a global public good, because as you know, and that's what we discussed last week, climate change has an incidence on people's lives and well-being. To continue on this matter, this map is actually, so this is a YouTube video where they are using supercomputers to reveal how carbon dioxide moves around the globe. So it's just to show you that basically, if you watch this YouTube video, and you can click on the link at home, you can visualize how CO2 is moving in space and around the globe. So it's quite impressive because actually some extra units so economic activity is generating CO2, right? And this moves really, so it's really a matter of a global public good, or in this case, a public bad, that we need to solve collectively because it's happening at a global scale. So progressively, it's becoming clearer and clearer that that climate should be considered from a global perspective, and not only at the individual level or at the country, at one country's level or horizon. So let's talk now about the history of cooperation efforts. So cooperation efforts, as I was saying, they started in the 70s in terms of cooperation efforts to affect the environment. And actually, they've changed quite a lot progressively. But what we can see here, so these are several examples of cooperation examples. So here you have the Rio Conference, so the Earth Summit in 1992. And then the Kyoto Protocol that you've probably have heard about. Then the Copenhagen Accord, with different, and each of these different summits has had different characteristics. Some were more binding than others. And the last one, probably the most famous one recently, is the Paris Agreement. That is a universal framework of national pledges to limit global warming below 2 degrees. So the idea is here that we try to reduce global warming, but in the case of the Paris Agreement, we have this idea of common but differentiated responsibilities, with all the countries making national pledges to try to reduce or to limit global warming, but at different levels. Nevertheless, despite this relatively long history of agreements, what we see here on this figure is that global CO2 concentration keeps rising, right? So you have the x-axis here that represents the time horizon, and what we see is that CO2 concentration measured in particulate matter here keeps increasing. So it suggests that we haven't yet solved the problem of climate change from a global perspective. But you may think that those those climate, those international environmental agreements, they're mostly a matter of geopolitics. And of course, it's an important matter. We see now with the latest Trump mandate, who, by the way, has dropped out of the Paris Agreement, that geopolitics matters quite a lot. But actually, behind those complex negotiations and politics, there are economic agreements, matters, economic factors. And those factors can be seen as the benefits, the perceived benefits or the perceived costs accruing to each different participant when a country decides to join or exit an international environmental agreement. So we are going to see how the benefits cost ratio can affect the incentive, the interest countries have to join, and how the actions usually depend on what others are doing. But if others are doing nothing, then what is your interest in changing your behavior, right? So that's what we are going to discuss, and we are going to see that we can use game theory to model countries' incentives and show how a free riding problem can arise. Okay, so let's move right away to the prisoner's dilemma. So I guess more or less you all know what it is, right? Okay. So I'm going to be brief on that one. Basically, the idea here is that there are two prisoners and they are held separately, so in two different rooms. So it's a very stylized state of the world. And each must choose whether to confess, remain silent, and without communicating. So they've done the mischief together, and now they are being questioned by the police agent or whoever. So this is just a stylized drawing that I've made with ChatGPT, but as you can see, all the arrows are in the wrong direction, so sorry about that. Obviously, it should all go this way for this person. So anyways, there are two prisoners, and if they both confess, they get 6 years each. If one stays silent but not the other, the one who confesses gets 0 years of jail sentence, and the other one gets the maximum penalty, so 10 years. And if both stay silent, well, they each get the minimal sentence, which is 1 year each. Sorry, this room is not ideal, but anyways. So you can, so either you see it that way, or you just can write it down from more of an economical perspective as a payoff matrix. So the idea of a payoff is what you're getting in general, and what we have here is with this payoff matrix is here the payoffs of player 1, here the payoffs of player 2, and their action. One can confess, one can decide not to confess. So here in red, I have highlighted all the payoffs of the player 1. So if player 2 is confessing and player 1 decides to confess as well, he gets -6, so 6 years of jail. If he doesn't confess, he gets -10, and so on. So obviously, you want to have the highest payoff as possible. So here, -6 would be more interesting than not confessing and getting -10. Similarly, for player 2, I have highlighted its payoff in yellow. And the trick here is that your payoff depends on what the other is deciding, but you don't know what the other one is going to do because you're held in separate rooms, right? So basically, there's a tension between what is good for you and what is good for the other, for your partner in crime. And actually, you can see easily that individually, the best possible outcome for you is to get, regardless of whether you're player 2 or player 1, 0, so no years of jail. And socially, the best possible outcome is to get here -2. Why is that? Yeah.
Because it's the biggest minus together.
Exactly. So you do, your idea is that you sum the two players of each player, right? And so in the green case, you have -2, and in this case, you have -10, here -10, and here -12, okay? So we can clearly see that confess is in a way the worst social outcome. So there's a clear free riding incentive because you can get -1 each, which is the best social outcome. But actually, if you don't confess, if you confess and the other doesn't confess, you can get away with 0 years of jail. So you try to play on this code, and this is where the free riding incentive takes place. So the Nash equilibrium is basically that we call the non-cooperative outcome is for the two players to confess, and we get actually the worst possible social outcome with this strategy compared to the cooperative outcome where both players would not be confessing, and we would get -2 instead of -12 that we're going to get in the Nash equilibrium. Okay. And so, how does this happen? Well, we are solving the payoff matrix by actually trying to understand what is the best response of each player in different scenarios. So just to solve the game very fast, basically, if player 2 decides to confess, your best strategy as player 1, what is this? What is it?
Don't. To also confess.
Sorry?
If player 2 tries to confess, you should also confess because
Yes, exactly. So you should confess to maximize your payoff. And so if the other, if player 2 this time decides not to confess, your best strategy is similarly is also to confess, right? So in both cases, you're going to choose confess if you are player 1. Similarly, player 2 in his room alone tries to think about what player 1 is going to do, and he starts thinking and realizes that if player 1 is confessing, his best strategy is to confess as well, and if player 1 is not confessing, his best strategy is to confess too, so overall he's going to confess. And that's how we reach this Nash equilibrium. That is a non-cooperative equilibrium. And why is this called a Nash equilibrium? Do you know? Okay, so not there was this economist was famous, but what does it mean, the non-cooperative equilibrium? Why is it an equilibrium? Yeah.
Because there's no incentive for both players to, like, how do you say, to go away from this equilibrium.
Exactly. So you have no incentive to deviate unilaterally, right? So no player can change their payoff by unilaterally changing their actions, and this is really the definition of the Nash equilibrium, but also of an equilibrium in general where it's stable in that sense, okay? So it's not the Pareto optimum because, as we discussed, we could actually have a better outcome. Both players would be better off if silent than at this Nash equilibrium that is where both confess. Okay. So this was a very stylish case. It is often cited, however. So I think that it was important as a reminder, but let's go back to environmental economics. Actually, we use the prisoner's dilemma because quite often we want to try to model the choice of economic agents. And here we are going to talk about countries. And the idea here could be how much a country tries to reduce pollution relative to doing nothing. So let's start with a basic binary decision where you can decide to abate, so to try to reduce pollution, versus to do nothing and to keep producing business as usual. This is just to show to you what it would look like, the payoff matrix. So it's again a stylized example that I have invented, but still it's to show to you that it's not only about the prisoner's dilemma, this prisoner's dilemma, it can be used to try to understand different countries' incentive to abate versus to produce emissions. And here you can do it at home, but you get the same example where ideally you would want both countries to abate, so to maximize the payoff and to have 15 plus 15. But what you're going to get is that both countries produce emissions and the payoff is going to be 20 instead of 30. So you can just solve the game yourselves if you want and see that the non-cooperative equilibrium is going to be different from the socially optimal outcome. And how can we move the players from the non-cooperative to the socially optimal outcome? Because this is the key, right? Because that's what we are having when we don't have the international environmental agreement. We actually have this exact situation where we would want people to emit less or to reduce pollution to try to reach the social optimal outcome, and we are not getting that. We are getting a non-cooperative equilibrium where everyone is polluting. Yes?
Are the payoffs already costs or utilities?
Here they are utilities, so the higher the better. Okay? And it was the same in the other one. The higher the better as well, but it was a negative example and this time positive, okay? So the real challenge is to try to understand how we can make people, make countries in that case, cooperate. And we're going to see, so we're not really going to talk about credible communication, but credible threats is something we are going to discuss during the seminar on Wednesday when we talk about trade agreement with the Nordhaus paper, enforcement, and changing the incentive structure. So this is all related to trying to make the agreement as credible, profitable, and stable as possible, as we're going to see. Okay, now bear with me, it's going to be mostly theoretical. We are going to look at the Barrett paper. So, what time is it? Okay. We have about 30 minutes to do it. Should be fine. It's not super complicated, but if you have questions, don't hesitate. If you want to come during office hours for the math also, but again, you have the whole appendix on Moodle now, so you should be able to easily derive it. And I think that after Frank Venman's lecture, you should all be very used to doing more complicated math than this. So the goal is to understand why countries struggle to cooperate on global environmental problems. So this is really a very important paper from Scott Barrett in Colombia. Yes, it's a bit outdated, but still it's an important building block where he tries to understand what is the key problem of cooperation. So it's a basic setup where there are N countries that choose how much to abate emissions, so how much to reduce emissions. So this is the key thing we're going to be interested in. It's really this quantity of abatement at the individual country level. And we consider that the total abatement, so the total abatement that is done globally is the sum of all the countries' abatement. The key economic structure in this model to remember is it's actually, I think it depicts the real world quite well, is that the costs are private, but the benefits are global, okay? So you're going to benefit from a less polluted world, but you pay individually the cost of abatement. Questions so far? All clear? Don't hesitate, okay? So the contention is the following. Countries, they pay the full cost of abatement, but they only receive a share of the overall benefits. So it's more or less this idea, like if you're doing a group project, some people may work a little bit less than others, and it creates a tension. We all face that. It's a simple framework, but nevertheless, it shows to you that individual incentives, they can differ from the collective optima. So what we do is that we're going to try to solve the non-cooperative equilibrium. So it's more or less the same thing as the payoff matrix, but this time we're going to solve it both graphically and analytically. We're going to compare it to the cooperative outcome and try to understand, can cooperation be self-enforcing, so without a social planner forcing everyone to do things, because at the global level, well, there's no global government. Okay. So it's really this idea of generalizing the prisoner's dilemma to several players. We are going to consider a problem of global pollution that involves those N countries. We denote QI, the individual quantity of abatement, Q, the total amount of abatement, and for simplicity, we will assume that countries are symmetric. So what does it mean in practice? How is this limiting? How is this interesting to think that countries are symmetric? Yeah?
Because if you would, like in an applied context, if you wouldn't have symmetric countries, then you would have, for instance, one country that's 99% of the economy and one country that's 1% of the economy. The 99% country will almost do what's socially optimum.
Okay.
Yeah, you can scale that.
Does this also apply to the cost structures in all the countries are symmetric?
Yes, so there are different aspects to it. Of course, if one country was like the biggest country in the world and all the small countries and the rest of the countries was super small, then we would just focus on trying to incentivize one country. So that's the first thing. And also the main advantage by assuming that countries are symmetric is that we can assume that they have the same cost structure, the same benefits. And actually, this may sound super simplistic. We know that in the real world, there are bigger players than others. There are also, as we were discussing last week, some countries and some people who have a higher damage of climate change. But in this model, it's actually quite nice to assume that countries are symmetric, because then we can focus just on the incentive structure and show that, and what he's showing actually, Scott Barrett, is that even for the most simplistic stylized model, you can show that cooperation is already very difficult to enforce. So now if you add the idea of different bargaining powers across countries, you can imagine that it's going to be even more difficult to enforce. So even in a simple world, he's showing that due to the free riding problem, international environmental agreements, they are difficult to enforce and they are difficult to implement. So what we are going to work with, so we have this QI, which is the quantity of abatement per country, and what we are going to work with is those two key functions, the cost for country E, so how much I, so the more you abate, what is your cost, and the benefit for country I, so how you benefit from abatement. To solve the model analytically, those functions, they are specified in the most simple way possible. So they are convex, and this allows to have the marginal cost, MC, and the marginal benefit to be linear, which is going to be extremely convenient when we solve the model. But again, it's to show that with a simple model, we can already see the tension between your individual interest and the social interest. So we are going to denote CI, the cost for country I, and the benefit for country I, B. And here you can denote that, you can see that there is a difference. For the cost, it depends on your own quantity of abatement, and for the benefits, it depends on the total quantity of abatement. And here lies the tension, right? So we are defining those functions, and basically, you can see that they are fairly simple and they are going to be easy to derive. So to show to you how it works graphically, we can just draw these two lines and have on the x-axis the quantity of abatement, so what we are trying to solve, and here the benefits and the loss. We can then draw the marginal cost of one country as the derivative of the cost function by Qi, and we are getting CQi, so the slope is C here. Okay. Similarly, we can draw the marginal benefit slope and line, and to do that, we just derive the benefit for country I, and we draw it here, so we get the marginal benefit. And as you can see, one of the tricks of solving the model, and again you have more detail on Moodle, is that Q, the total quantity abated, so the global quantity of abatement, can be decomposed into Q tilde, what the others abate, and Qi, what you abate. And this is going to actually even further simplify the resolution of the model. Questions so far?
What's the meaning of A and B?
What's MB?
What A and B mean in this equation?
So these are just parameters at this stage, but actually B, it's going to be the slope B over N, right? Is the slope of the marginal benefit curve, meaning that the higher B is, the steeper the curve is going to be. And A, it's going to be the intercept. So you have here, you would have this point equal to A times B divided by N. But these are just parameters of the model to have the intercept here, and then the B divided by N to be the slope. And we are going to see later how the value of B actually matters for the results on the coalition.
The Q is abatement of country I or all abatement in the game?
So capital Q is the sum of all the abatements. Okay? So if you have n countries and they are symmetric, it's equal to n times Qi.
Oh, but the benefit's divided by n because it's benefited only by country, by a country.
Here, yeah. But it's just to have this intuition that it's you benefit from the total abatement as a portion of this total abatement. Okay. Wait, other questions? Okay. So it's really this idea that you do benefit from the abatement made by others, right? And all the abatements, in this case, all countries abate the same quantity because we are assuming symmetry, right? And actually, in general, you only consider your own when you solve a maximization program. You tend to only consider your marginal benefit. But if you were really accounting for all the benefits of other, you could look at the total marginal benefit. So the marginal benefit, how much all the countries benefit from one additional unit of abatement. And this is what we are drawing here. The total marginal benefit is equal to the sum of all the marginal benefits at the country level. So we can, here we have the marginal benefit, right? And if I were to draw the total marginal benefit, what would the slope be? The slope for the total marginal benefit curve. Yeah?
Just minus B?
Exactly. So it's just the sum of all the marginal benefits, and given that here the slope is minus b over n, you would just multiply this by n and get minus b. Okay. So you have the total marginal benefit that is equal to the sum of all the marginal benefits. And the idea here is that we're going to try, similarly to what we did with the simple payoff matrix, try to find what's the equilibrium. So in general, why is the marginal cost at the equilibrium? Why is the marginal cost equal to the marginal benefit? Yeah.
Like, how should we interpret the meaning of like the TMB curves? Is it really like the standard definition of a marginal benefit curve? Like, if I would abate one more unit, what is the like marginal benefit to the entire world? Is that how we should interpret it? Or?
Yeah, I think that the interpretation is really how do all people benefit from one extra unit of abatement. But why is the marginal cost equal to the marginal benefits in the standard econ theory at the individual level? Yeah.
I mean, it's a classical utility maximization question, because if you would go one further, you would actually incur more cost than the benefit you get, and that doesn't make sense, and like similarly the other way around.
Exactly. So we are trying to find the optimal quantity of abatement so that you're at a stable point, so you don't want to abate 1 unit more and you don't want to abate 1 unit less, okay? So this is what, and basically, graphically, it shows as where the marginal benefit and the marginal cost curves interact. So basically, it's here, right? That you have this intersection. So it's really this intersection, it answers the idea where how much should country I abate taking others' effort as given, okay? So you just look at your own quantity of abatement and you account for the rest of the countries as a given decision. And it's more or less the same idea as when we were solving the payoff matrix of the prisoner's dilemma, where we were asking ourselves how much should player 1 react if player 2 is confessing, versus how much should player 1 react if player 2 is not confessing. So it's more or less this idea of like you cannot influence the other one, you just take it as given. And so the non-cooperative equilibrium, I kind of gave that away. It's of course here where those two curves interact. And so what's the difference between point 1 and point 2 here? What's the difference? Who hasn't spoken that much? You? I think you haven't spoken that much. Yeah?
Sure. So point 1 is basically your what you actually have. Point 2 is where you want to be, because point 1 is basically you're looking at your own personal benefit as opposed to sort of total cost. And point 2 is where you're actually considering the benefit to everyone, which is what we theoretically want.
Exactly. So the idea of point 2 is that this is where the social optimum lies. It's really what you would be doing if you were to account not only for your own payoffs, but also for the rest of the countries. So basically, as you can easily see, the quantity of abatement that is made here at point 2, if you look at the x-axis, it's higher than here at point 1. And this is really this tension that we have, that the social optimum is going to be higher, that the quantity abated in the social optimum is going to be higher than the quantity abated in the non-cooperative equilibrium. Okay. Bear with me. We're almost done for this first part. I know it's a bit intense, but let's make it more alive by asking questions. Don't hesitate, because it's not an easy thing to do it in a very interactive way, to be honest, so sorry about that. But anyways, basically, you solve the maximization program at individual level. You get, you derive the model by QI, And you have this equality between the marginal cost and the marginal benefits. So this is how to solve analytically the model compared to graphically. Okay, so that's what I was telling you. Here you get the non-cooperative equilibrium point. That is the quantity of abatement at the non-cooperative equilibrium that we are going to denote Q and C because it's non-cooperative. Okay? Okay. Now turning to the cooperative equilibrium. How do we get it? The non-cooperative equilibrium, basically, it's when countries jointly maximize their aggregate utility. So what we were discussing earlier, and it solves the question. It answers the question: what level of total abatement? So this Q in capital letter is best for everyone combined. Okay. So here, instead of solving your own program, your own maximization program, you solve the program, but this time you look at the sum, okay? And that's how you get the total as the first order condition that the total maximum, the total marginal benefit is equal to the marginal cost. And that's what you get if you do it graphically. That's what we were discussing, right? So we can clearly see that the Q cooperative, so the quantity of abatement in the cooperative equilibrium, is much higher in that case than the Q non-cooperative. And interestingly, on this graph, you can see that even in the non-cooperative equilibrium, because all countries still benefit from abatement, each country still have a little, will still do some abatements even in the non-cooperative equilibrium. So each country will, the model predicts here, due to the functional form chosen, that there will still always be a little bit of abatement done, regardless of whether we are at the cooperative or the non-cooperative equilibrium. Okay, so basically this tells you how to solve the cooperative equilibrium. You can see the trick. Again, you have all these details, so I'm not going to enter the derivation because I think it's going to be super tedious. Yes?
In the previous graph,
Yeah.
is this example only where there's only one country that pollutes, right? And the other countries don't pollute?
No, it's actually, sorry if I wasn't clear. All the countries are polluting, but I'm just showing to you the decision of one country because they all behave the same.
I was thinking that wouldn't the marginal damage of pollution change based if the others pollute as well? Wouldn't it increase if there's already a lot of pollution from the other countries? Your marginal damage of pollution would also be higher, not because you're at a further point.
Yes, so here we're looking at it from the symmetrical point of view, right? Where we're looking at abatement and not pollution. So instead of the damage of pollution, we are looking at the benefit of abatement in this model. And indeed, that's what you can see. The more, so this is your total marginal benefit. So what you get when taking into account what all the others are doing, and you can see that it is higher than your own marginal benefit. Okay? And the quantities of abatement, they sum up across countries. So the more abatement there is, the more you benefit. Okay? Look, if you, that's what you can see here. The benefit for country I, it's equal. It depends of the total amount of abatement that is being produced in that case. Okay? Is it clear? Do you want me to go again? Because I know that it's not that easy to do at first.
For this thing, like looking at this total consumption, like if now looking from the point of the country that we're looking at, if Q is higher based on the other ones, the marginal rate of abatement, the marginal benefit of abatement is higher if pollution from abatement from others is lower. I guess, no? Like if it's low from all the other countries, the marginal abatement would be higher for the individual country because it's all higher already, no?
So you always benefit from more abatement, but it's the idea of a convex function where initially the first few units of abatement you benefit a lot marginally and progressively decreases over time. Okay? Is that clear? But you always benefit from more abatement. It's more that there are diminishing returns.
Yeah, so I'll go
Okay, we can do that again. So it's really this idea that, like, if you imagine that a place is super polluted, for instance, the more you depollute, so the more you abate, the more you're gonna. At the beginning, it's very you benefit a lot from the first few units that are being abated, and then progressively less and less. So if you move from, if you think of India that is sometimes very polluted due to crop burning, for instance, when you stop that, you're going to benefit a lot initially, but the next few units of abatement, you're going to still benefit, but less and less. Because your health is not improving as much in a way as with the big initial jump when it was super polluted. Okay. So the idea here is to solve the model to try to find the analytical value of, to try to find the value of Qi from an analytical perspective. And you can do it, you will see that easily you get to the point where the two, the marginal curve and the marginal cost and the total marginal benefit, they intersect. And here you have even further details on how to solve the equations at home. Okay. So when are the gains of cooperation high? Basically, you're going to get to this point if you solve the model at home, where the cooperative equilibrium is higher than the non-cooperative equilibrium. And you can see it here because you have the same thing in the numerator, okay? You have AB. And here in the denominator, you have B times N plus C. And here you have B times N plus C times N. So you have a higher denominator in the non-cooperative equilibrium, meaning that the total value is going to be smaller compared to the cooperative equilibrium. So basically, this direct model can now be used to answer the two following questions. When are the gains of cooperating high? When do we most need cooperation? And we are going to see that based on the model, it's really when the total marginal benefit and the marginal costs are steep, so they have a high slope. And when can a coalition sustain cooperation when it's most needed? So basically, can we achieve international environmental agreements? And according to this model, it's a bit of a dismal conclusion. The answer is going to be no. But we are going to end up with a more positive conclusion when we look at the Nordhaus paper during the seminars. Okay. So, if we stick for now to the graphical analysis, yes.
A question on that. So given that climate change is a stock pollution problem, not a flow pollution problem, the marginal benefit of one additional unit of abatement should be quite low, no? So would then the model not predict that we actually get cooperation in the climate change case?
Well, I tend to agree with you that the marginal benefit tends to be low. In this kind of model, you can more or less have everything, right? Because it's just a model, so it's going to give you a set of cases. But it's true, we are going to see that, for instance, in one of the agreements we're going to discuss later on the ozone layer, actually the marginal benefits were relatively high and the costs were relatively low. So in that case, cooperation can take place. But in other cases, it's true that the lowest the marginal benefit, the more people there are also to, we want in a coalition, so if with 250 countries, obviously it's much harder than with a small number of countries. So you are right in the sense that basically the key determining parameters of the model conclusions are going to be B, so the total marginal benefit, the C, the slope of the marginal cost. So if it's very, very costly to abate, well, countries have a low incentive to abate, right, to reduce pollution, and N, the number of countries. So graphically, basically, this blue triangle, it shows the gains from cooperation. So this surface here, it can really be seen as what we are gaining from moving from the non-cooperative equilibrium to the cooperative equilibrium. So it's basically, it can be seen as a gain in utility. And here, this is what we are getting with the non-cooperative equilibrium. In green, what we are getting in terms of utility in the cooperative equilibrium. And so the difference between the two is really this blue triangle I was just showing to you, where we are, that allows us, this surface, to compute how much analytically we would be winning from having an international environmental agreement. So that's what I was telling you. So here you have the variation in Q, this variation, and you get how much you are getting. And so how do they vary with the slopes of the total marginal benefit and the marginal cost? What do you have in mind when you see this? Because this is just C and B, it doesn't tell you much. I could set any value, right? If you answer this question, you get a break. Yes.
Maybe more of a question. The delta U, from my understanding, the arrow should only go halfway up, no? Not all the way, like to the level of the green point. Why is it like the entire span?
This?
Yes, why is it the entire red line and not just up to the level of the green point?
It's just to compute the size of the triangle, but I don't see. Your idea is that it could stop here, because that would be the difference between the two?
Yeah. Yeah, if utility is the area of the triangle.
I think it's just to compute the area of the triangle that you need to have those two sides. And this tells you the variation there is between the marginal benefit right here and the TMB here. But yeah, it's just to solve the model graphically rather than analytically. And so how would B and C, so the slopes of those two curves, influence our results?
Yeah, coming back to like his question, I think that like for every additional unit you abate, you get like the marginal benefit is like the difference between the total marginal benefits and the marginal cost. It's like or surplus, so that's why we need the entire area, because it's like at every like unit between Q and C and QC, it's like that's the like marginal benefit, so that's why we need the entire triangle and not just half of it.
I meant more the level because the utility is the area, but like the distance is not U. The distance would be the numerator good or the cost or whatever, but it's the area that is U. So del U is not the length but the area.
Yeah, it's just this idea of computing the area. But going back to this idea of the values of C and B, that is for sure.
You could basically have B and C both as large values. So the larger the value, the steeper the slopes, and that would basically expand that triangle. So you would eventually have a larger triangle.
Exactly. So the smaller the B here, the closer those two slopes are going to be. So in that case, it closes the gap between the non-cooperative equilibrium and the cooperative equilibrium, right? And similarly for MC, if MC, so the marginal cost slope was to be very small, there would be less benefit from cooperation, okay? So the tension arises from the fact that there is a gap between the total marginal benefit and the individual marginal benefit, and the fact that abatement is costly. If abatement was to be cheap, then we would not a priori need international cooperation. Okay, great. So we'll next turn to whether a coalition can sustain cooperation when it's most needed. But first, let's have like a 5 minutes break, and we can start again.
Also du hast keine utilitäre Ellipsoidachse, sondern bei der Wirkung.
Yes. I don't think it should be seen. Even though it tries like delta U, it's not really this the variation.
The axis is not units, no?
No.
So the distance that we're measuring there. Exactly, but so the distance that we're measuring is not delta U. Delta U will be the area, not that arrow.
I mean, delta U is just how it's written for the right?
Yeah, my confusion was just
it's what
the axis is quantity, and then you have, let's call it the numerator good.
Exactly. And I think
in the end, it's the area. Exactly. Not the arrow there.
not because it's more like Q as in
unit of something.
It's confusing when we are thinking of like how to
Auf der X-Achse stimmt's ja.
Your friend is London. See.
Yeah, okay. Yeah, also.
CKK square. Exactly. That's what I was trying to say. But she's like
First thing she was like,
Thanks for the advice on how to get that website.
You know, even selfish. So, like even selfishly, so you would have paid if people don't obey, you would have paid. Yeah, you obey.
And that's the tension, right? So everyone is benefiting from having a high level of advancement, but no one wants to.
Okay, yeah. So it does matter.
The others do matter. From the fact that just you have skills that is equal to the I think that is something
No, honestly, I think I just had to like understand what my confusion was first of that.
Okay, that's
Put your own level, you pay the cost of your own extra work. You don't.
no, but wait.
But the others don't pay for the extra work that you're doing. So your marginal cost, it's really just related to how much you are paying, not at all how much the others are paying. You pay your own cost and you benefit from the abatement of others.
whether he can do it. It's nice. I was actually thinking of that.
No, but let's ask it.
Yeah, you could think of it. If it's the exact same as the TMs.
it depends on like the
And
origin.
also if you like
Or the thing is that the
Yeah, someone again.
Sucks. You've never actually been I have, but like, I don't think it's like, show me around, show me around. Wow. So what we should do like show you my Sunday itinerary. Best. That's actually like the best thing to do in the summer, like
because you only pay for the quantity that
whatever Steven says goes.
Consider the amount of hours you are putting in.
Days for each other. Are you here for the
you wish.
Guys, let's get back to it. We have 45 minutes to discuss whether a coalition can sustain cooperation when it's most needed. And then we will discuss different types of international environmental agreements in light of the Barrett paper. So, the idea of a coalition is that we are trying to coordinate emission abatement as a two-stage game. So before we were only thinking of about the quantities of abatement each country was abating, so this QI, but now we have this idea that countries, and what we saw from the previous part is that the cooperative equilibrium was yielding more abatement, so a better environmental outcome than the non-cooperative one. Now what we are going to try to understand with the Scott Barrett paper is whether countries enter or not the coalition. And the very idea of this part is that one cannot, there is no global entity that there is no supranational entity that can force countries to enter or exit a coalition. So we want every coalition to be self-enforced and in a way sustainable, meaning that no one leaves and no one enters. So there is this idea of coalition theory that is modeled as a two-step game, where first countries have to decide independently and simultaneously, so at the same time, whether they want to be in a coalition. So it's really this idea that, like, if I want, you ask, like, you try to imagine countries as deciding all at the same time whether they want to enter the coalition. They cannot observe how it's working, whether it's working well or not before entering. And the second step is to set the level of abatement. So the idea is that people in the coalition, they will all play as one, so they will all have the same amount, do the same amount of abatement, and maximize the aggregate payoff of the coalition, whereas people or countries who stay outside the coalition, they will pursue their individual optimal abatement policy. So this is where the tension lies. We want to understand whether non-signatories are going to free ride or not. And it's always this tension of abatement being costly and everyone benefiting from abatement, okay? So of course you would ideally want everyone to contribute to the public good, but yourself, you don't want to pay the cost of that. You want to get the benefits of that. Obviously, it's a very individualistic vision of the world. There can be a lot of other considerations, but in this kind of model, that's what we are thinking about. A very rational, not socially influenced agent. So the tension here is that, as I was telling you, there is, it's not possible to force countries either to sign or to withdraw from the agreement. So the agreement must be self-enforcing in the sense that people who have joined want to stay and people who have not joined want to stay out of it. Otherwise, there is no equilibrium, right? People keep entering and exiting while we are not in a stable point. So for that, we need to satisfy two conditions that are profitability and stability. So if we denote alpha the share of signatories, and we assume that there are n countries, so alpha times n is the amount of countries in a coalition. We can also denote P the payoff of a country. And we define the condition of profitability as the fact that no signatory can gain by withdrawing from the coalition. Why is that? It's because if a signatory, so as I was telling you, we are trying to find the conditions so that we find an equilibrium in terms of the amount of people joining a coalition. And the idea here is that every time a signatory drops out, it will change the size of the coalition, so from alpha to alpha n minus 1. So the new share of signatories will be lower than before by one member, right? And so the defector would then be a non-signatory in a smaller coalition, earning this time P alpha minus 1 out of n. And so for the coalition to hold, it means that the profit of the signatories alpha, so the profit of alpha of having alpha n people in the coalition should be higher than being a non-signatory from a small coalition. So basically, in each case in this model, your payoff really depends on the share of people in the coalition. It's like if you think of your friends joining a club, and when the club reaches a critical size, you kind of want to join. Okay, so so this was the condition for profitability. You always benefit more from being in the coalition than outside the coalition with one less member. And stability is the idea that no non-signatory, so people outside the coalition, can gain by unilaterally entering the coalition. So there's no one who wants to join the club in a way. And otherwise, as you can tell, the coalition would grow from alpha n to alpha n plus 1, so you just add one member. So the new share of signatories this time is alpha plus 1 out of n. And the newcomer would then be a signatory in a larger coalition, which would affect the payoff of everyone. So for the agreement to hold, we must be no better. The person outside must be no better than when joining. So it's really those two ideas that make an agreement, according to Scott Barrett, self-enforcing. Yes?
I can very clearly see the idea of why people shouldn't be incentivized to leave the coalition. What is the intuition between them not joining? Because surely it must be in the interest, for example, the climate agreement like Paris, to, if the US would want to join again, then it would be profitable for them to do so.
Well, does anyone want to answer?
I believe we have a single stage model, so it's mostly about having stability in the outcome. It's not like a multi-stage observation that we're making here.
Exactly. So it's more or less the same idea as the marginal benefit equaling the marginal cost, right? You want to try to find the point of stability. So it doesn't mean that, like, ideally you want the bigger coalition possible, but when trying to find a stable agreement, you want to make sure that you have a stable amount of people in the coalition. It's really this idea, more in like marginal thinking than overall. Okay? And what is the problem with those two conditions? When you look at them, what can be the problem if you see one?
Yeah. Isn't there a problem if both hold an equality?
Sorry?
Isn't there a problem if like both the equations hold an equality?
Yeah, so the problem indeed, like just very intuitively, is that they more or less push in the opposite directions, right? Like on the one hand, you want the profit of non-signatories to be lower than the profit of signatories, And on the other end, modulo the alpha, etc., modulo the shares, but at a marginal level, those 1 divided by n and plus 1 divided by n don't matter that much. And you want the profit of the non-signatories to be higher than the profit of the signatories. So that's exactly what you are talking about. There is really this tension where if it's a really nice coalition, people will be joining, and if it's a really bad coalition, people will be exiting. So, so there's a clear tension here that is being put forward by Scott Barrett in that paper. And so here I have written it with a lot in a very wordy manner. It's really the cruel logic of those two conditions together. They pull in opposite direction, and they are very hard to satisfy simultaneously for large coalitions. In a way, if being inside isn't too costly relative to defecting, well, you benefit from the fact that a lot of people will abate a lot, so you have an interest in not paying the cost and exiting the coalition. And in other cases, there is no incentive to join in the case of stability, so it's really like those two conditions that create a tension. And so, would it ever be profitable to join? Because the whole point of this lecture is to try to understand when people are joining. How come is it possible that countries would find it profitable to commit themselves in abating, given that it's costly and that they know that others will have an incentive to free ride? I think that the example of the US is something where we should be a little bit careful, because they emit so much that really when they leave a coalition, it kind of disrupts everything. And it's unclear whether they would benefit from the fact that a lot of other small countries would abate a lot. I mean, probably at the margin, but it's here we are thinking of a model that is quite simple, where there is a symmetry. Countries more or less have the same bargaining power and the same size. So shouldn't free riding always make countries better off? So the idea is that the reward when a country joins is that everyone abates a little more, so everyone has their benefit function that increases. I mean, they move up the benefit curve. And when the country leaves, everyone abates a bit less, so it's the punishment, you move down the benefit curve. And so this is the key mechanism underlying self-enforcement, is to try to find to satisfy those two conditions. And so basically, in the paper, he shows that compared to the non-cooperative equilibrium, the coalition equilibrium is in between the non-cooperative equilibrium and the cooperative equilibrium. Why is that, in your opinion? Why do we have this in between? Yeah.
It reminds me a bit of like a perfect market and like a monopoly, where like if you have like a cartel, it's always in the middle, because you have sort of as if you would have a few big countries. Approaches each other.
Yes, it's a bit of this idea. It's mostly that due to the coalition, you will always have some free riding, and given that you cannot force everyone, you don't reach the best social outcome.
Maybe I don't
But it's a bit of this idea of an in-between solution.
Maybe I don't understand the model, but we're still assuming symmetrical countries now.
Yes.
Then why would we ever have a solution in between? Either they all join in the coalition and then we're at the TMB, or they don't.
Yes, that's a fair point. So we're assuming that people in the coalition, all the ones who have joined the coalition are symmetric.
And the other ones outside.
And the other one are also symmetric in a way, because it's really this two-stage process from what I understand. So first you decide whether to join, but this is not really the solution of the model with a coalition. It's just to give an example of how with a coalition you would reach an in-between that is not up to the level of like where everyone would reduce the sufficient amount, but it's still better than the non-cooperative outcome.
So this would be a sort of a high cost, low cost model of like players. The ones with the high costs will not, and the ones with the low cost will join, and then you have something in between. So they're homogeneous on both sides of the divide, but heterogeneous between the divide, or?
I think that it's in this model. It's simpler than that. It's really this idea that you try to understand how much people would debate if they are in the coalition, and I think that the ones who are not in the coalition, they would debate like more or less debate more or less this. But I will double check.
To Julian's point, isn't the question, because what you're saying is that all the countries should act the same if they're the same, and I think that it's just would be then what the stable size of a coalition is, and it would be 20 coalitions of 5 countries, I believe, instead of like one coalition of 5 and then the rest would do something else, because that would be illogical.
Your point is that at this stage we are choosing the number of coalitions.
So I think basically, if I understood correctly, what we've been doing up to now is like, okay, where it's like the stable point to what's the stable coalition size, but then all countries would act in the same way, and they would, I think, if it would converge to that you would have like then multiple coalitions that are smaller, like multiple small coalitions. But maybe I'm wrong.
I'm not sure, because to me, in such a simple model, it would be equivalent to have many coalitions with a few. I need to double check that, to be honest. I'm not really an expert of this game theory, international environmental agreement, so I will double check and give you the answer during the seminar. But the key idea is really to try to understand whether, so how the quantity of abatement can compare in the coalition system, can compare to the cooperative and non-cooperative equilibrium, and whether the enforcement can be self-enforcing. And this will all depend on the values of B, so the NC, the benefit cost ratio, and N. And this actually in the model determines whether the large coalition is hard to sustain. But I really think that in this model we are more looking at the number of countries that determine how large the cooperation problem is, rather than the number of coalitions in the model. So basically, the simple intuition here is that the more people you have, the more countries you have, the harder it is to reach a coalition. And here is a simulation. Maybe it will be helpful. So we have the payoff of the non-signatories here, and the payoff of the signatories here, PS, IS. And basically, the parameters are set as follows. So we assume that there are 10 countries, that B equal 1, and the slope of the marginal cost curve is 0.25. So you can define the global benefit as follows, with alpha, if you remember, being the share of people in the coalition. And so what we have here is alpha on the x-axis. So here you have everyone who has joined so a coalition that covers all the countries, and here you have no one in the coalition, okay? And basically what we can see is that the payoff of the non-signatories tends to be lower than the payoff of the signatories for small coalitions, until we reach a number of about 4-ish countries, and then the payoff of the signatories is smaller than the payoff of the non-signatories. So where there is this gap between the two curves and the payoff of the non-signatories being lower than the payoff of the signatories, it means that there is this incentive for free riding. And what he finds in the paper is that international environmental agreements, they will only sustain with a small number of countries. So that's why we have this idea of stability and profitability being respected. Okay. And so following up on that, there is, sorry if it's a bit small, you have, he draws like a set of simulations where you have a set of values for C and a set of values for B, the two parameters that we were discussing that determine the slopes of the marginal benefit, the total marginal benefit, and the marginal cost curves. And basically, what we can see, so here, those numbers, they are the numbers of countries in the coalition. And we can see that the higher the cost, the higher the benefits, the smaller the people we have in the smaller the number of countries in a coalition. And why is that a problem? To have high Bs, high Cs, and a low number of countries joining a coalition. Yeah.
Oh, it's not going to be as effective if a few countries will participate and they will have to do a lot more. Thus, the distribution of abatement will be less efficient, not because they will have to. They'll be incentivized to abate more as they're less.
Yes, so you need more abatement, meaning?
It's less efficient, the abatement, no? So if everyone doing the same amount, some will have to do more.
Yes, actually, the key, yeah.
Wouldn't with both high benefits and cost, wouldn't actually the gains of cooperation be really high, but we see that there's actually very little.
Exactly, I think that's what you are pointing to as well. It's that when when B here and C are high, so the curves are steep, it's really then that the non-cooperative equilibrium yields lower payoffs compared to the cooperative equilibrium. So there is this tension where we cannot achieve a coalition when it's most needed, in a way. And that's what the paper, that's the main conclusion of the paper, is that it's very high to reach a coalition when it's really needed. So now let's try to interpret the history of agreement of the climate and ozone treaties in light of this theory that is telling us that international environmental agreements, they emerge really when they are the least needed. When we most need them, they are doomed to fail. So for starters, let's talk briefly about the Kyoto Protocol. So you may have heard of it. It's an example of deep cooperation in the sense that we were in this protocol, most countries were concerned. It's not a narrow cooperation focusing only on industrialized countries. And actually, it's the first major international treaty to set binding emission reduction targets. So the goal was to reduce emissions below 5%, by 5% below the 1990 levels by 2012. And it has introduced a set of policies, including carbon markets, for instance. There's this video that you can click on. on YouTube that explains very simply why people are leaving international environmental agreements in the case of the Kyoto Protocol. And the key here is that in the case of this protocol, there was no enforcement mechanism, so basically no penalties for non-compliance, or very little. So the US decided, initially were in favor of it, then they decided to refuse to ratify it in 2001. And it also excluded developing countries who started representing a growing share of emissions. And it was actually part of the argument of the US that they were not going to pay the cost of abatement when other countries were emitting quite a lot. And progressively, it's really the example of a non-stable coalition, where here we have the percentage of emission covered as the emissions covered as a percentage of the world, so this idea of a set of countries. And here you have the Kyoto participants over time, and what we see is that the Kyoto protocol initially had a lot of people, and then it decreased and decreased, and that's what Nordhaus discusses in the American Economic Association presidential address. So there's really this idea that progressively countries were dropping and exiting and exiting the Kyoto Protocol, and now it's a bit of a non-working international environmental agreement. So the lessons learned from that is that in Copenhagen 2009, there was a tentative to negotiate for a stronger Kyoto Protocol that failed, and they decided to shift from a top-down approach, meaning a top-down approach that everyone should try to reduce emissions by 5%, say. So more or less everyone treated the same. Two, voluntary pledges, and that's actually what we have in the Paris Agreement that has been ratified by a lot of countries, even though some have left, as we were discussing earlier. So basically, in the Paris Agreement that you may know, it's a framework of voluntary pledges. So there is not anymore this focus on mandatory reduction. This has allowed countries to set their own targets, and with an overarching goal of limiting global warming below 2 degrees Celsius. So as you may know, the idea was to limit temperature rise below 2 degrees Celsius. It seems that it's not working very well, according to a lot of scientists who are we will soon reach this target. So it's not a super successful agreement in terms of the effects on global warming, but still it was seen as a success at the time because it was adopted by a large number of countries. And here there was 194 parties in December 2015 when it was created. So it's a legally binding agreement, but not economically binding. So there are no clear economic sanctions for the ones who don't abate enough. But there is the only mechanism in terms of enforcement is really naming and shaming and soft reciprocity. So the pledges are being reviewed every 5 years. And the hope is that progressively it will lead to deeper cooperation. It will, and also it gives visibility to the topic of global warming in a lot of countries. So, according to you, what are the chances for success for an agreement with 194 countries or parties and no enforcement, no clear enforcement mechanism? Not great. Yeah, well, it doesn't look that great. And according to the Barrett model, either way, it's a case of potentially limiting global warming. It has very clear gains, so the benefit is high. But there are also strong free riding incentives, especially with such a high number of countries being part of it. And with no enforcement mechanism apart from name and shame, the cooperative outcome is very unlikely to be reached, right? But we'll see during the seminar that William Nordhaus, the relatively recent Nobel Prize, has more optimistic conclusions and shows how with trade we can enforce international environmental cooperation. So that's something we're going to discuss on Wednesday. But before that, let's look at one agreement that has actually been super successful. So I don't know if you remember, but when I was a child, we were talking quite a lot actually about the hole in the ozone layer. It was all over the place. And the challenge with the hole in the ozone layer is that basically the ozone layer, it filters ultraviolet from the sun. And so having a hole in it, it leads to quite a lot of potential skin cancers, cataracts, scalp damage, so a lot of damages overall. So in 1974, there was this article that was more or less theoretical in Science, suggesting that well, I really struggle to pronounce this one, but like chlorofluorocarbons, I'm going to call them CFCs from now on, were destroying the ozone layer. And they discovered a few years after a large hole in the ozone layer over the Antarctica, actually quite near Australia. And after that, there was this Montreal Protocol, where officially, right after the Montreal Protocol, they attributed the hole in the ozone layer, so you can see it as environmental damage, to be attributed to those substances, the CFCs. And actually, there was this treaty that was signed in 1987, so the Montreal Protocol, that focused on the phase out, so the reducing the usage of the CFCs that were used very widely, because basically they were used for AC, for instance, in cars. They were used in the industry. They were used in a lot of different aerosols, and so they were very widely used. But nevertheless, the focus of the Montreal Protocol was to include trade restrictions on non-participating countries. So that's the key enforcement mechanism, is to tell countries, well, if you continue to use those substances, we're going to start trading with you. And this actually worked quite well. Here you have the timeline, and here you have CFC's consumption. And we can clearly see that the world consumption has dramatically decreased after the Montreal Protocol. It's like extremely striking. And now you see it's like really flat. We reached zero CFC consumption. So in this agreement, it was really like the enforcement mechanism was trade restriction, but also they provided funding for developing countries, so lower income countries, to switch to alternatives and participation incentives as well. And so the outcome and the main lesson to remember from this protocol is that it's the first treaty to achieve universal ratification. So that's why, like the world, we see a lot of countries here, but we see that overall the world has stopped using CFCs. CFC's emissions dropped rapidly, and now the ozone layer is recovering, and we talk much less about it. So, talking about the enforcement, basically, when we compare the Kyoto Protocol and the Montreal Protocol, there are massive differences. So in the Montreal Protocol, there were trade restrictions. In the Kyoto Protocol, there were financial penalties for non-compliance, but they were never really implemented, and compliance was therefore forever delayed. There were side payments from few countries to others, so industrialized countries to developing countries in the Montreal Protocol, whereas in the Kyoto Protocol, those funds and those contributions were voluntary and seen as small and unreliable, so not really encouraging countries to abate more. And so the bottom line is that Montreal made defection costly and participation to the International Environmental Agreement attractive compared to the Kyoto Protocol. And actually, how much time do I have left? 10 minutes, perfect. And actually, there's a massive difference between those two agreements. It's also that, what do you think is the key difference between apart from the implementation bits? Yes.
Well, I think it's a difference, but it's also kind of a question, because my understanding is that the CFC's industries had less political power than the industries that, what are they called? That extract oil.
Mm-hmm.
So it's kind of harder also to control or for countries to be interested in joining those agreements.
Yeah, that's a very good point. Yes.
I think one crucial point is that there was very clear and somewhat easy substitutes for the substances, so the marginal cost of action was relatively low in comparison to the benefit.
Someone wants to add something? Yeah.
And there's much less point sources also in the Montreal, so it's a much smaller number of places that need to be controlled.
Yeah, so all very relevant ideas. Indeed, one of the main things is fewer, easiest to control. Also, we are not really talking about energy consumption that is used everywhere, in every sector that we are trying to limit when we think about climate agreements, right? The ozone protocol, as you said, it's more or less a few industries, even though very important industries like AC, so cars, which made actually the trade restrictions quite credible. But nevertheless, the access to substitutes has probably helped, or the fact that at least it was a few molecules compared to CO2 emissions that arise from a lot of production processes. So indeed, so both examples are, in both examples we are talking about global public goods and in particular environmental goods, but there are key differences, and I'm not going to enter the diplomatic differences. But nevertheless, there are differences between those two agreements. And actually, the outcomes of collective actions have been drastically dissimilar. And so the question here, going back to all what we've seen during this lecture, is whether theory can explain why we've had a successful agreement for ozone depletion and not for climate change. Well, actually, this is briefly mentioned in the Barrett paper, despite the fact that this was a while ago, that according to Scott Barrett, the Montreal Protocol, it's a case of low gains to cooperation, making it easy to set a coalition. So people had less interest to free riding. And so in this paper, Eugenie Dubois, what she does, because she has an empirical paper on the Montreal Protocol that is, I think, quite interesting, published in Restat last year. She studies induced innovation and the Montreal Protocol. So basically, induced innovation is something we're going to discuss next week. It's the idea of like policies creating innovation, contributing or fostering science and innovation. And the question she's raising is, were the substitutes to those harmful substances targeted by the Montreal Protocol already existing, or has this protocol fostered innovation? And to do that, that's her specialty really. She works with patent data to study how science has evolved over time. And in that case, she's tracking different molecules in the patents to try to understand how the Montreal Protocol has influenced innovations. And so basically, you can see it in the paper. She uses difference in difference as well as a synthetic control method as a robustness check, and she checks how hazardous air pollutants that are other types of industrial molecules but were not targeted by the Montreal Protocol have been affected compared to CFCs that were directly targeted by the Montreal Protocol. So this is really this definitive where she does the before, after, the control group, those hazardous air pollutants, and the treated group, the molecules of the CFC. And she looks at the patent and how they have evolved over time. And she shows that the Montreal Protocols has caused a large increase in innovation on CFC substitutes. So actually she finds quite a massive effect with an increase by a factor of 4 in patents and 500% in scientific articles, suggesting that the Montreal Protocol has really boosted innovation, and that the effect took a little bit of time, because if you remember, the Montreal Protocol was signed in 1985, so she starts observing effects after, with a little bit of gap over time, suggesting that innovation took place after the Montreal Protocol was implemented. Yes.
It's just an idea that popped up now in my head. Was that really genuine innovation, or were those compounds that were known but there was no incentive to patent them because you could just use CFCs, and now that you couldn't use those anymore, there was a race to patent those for commercial exploitation? Or was it actual, real scientific knowledge that was gained?
So I'm going to come back to your point. I'm just checking the next question because we have like 4 minutes.
I wanted to answer that.
Okay, well, if you want to answer.
I believe it says in the paper that the ramp up was like mostly 3 years later. That indicates that like otherwise you would have patented it right when you like knew that it would be happening. So it seems like they started developing then when sort of that became a thing.
So indeed what she's doing in the paper is really study this dynamic story to try to understand what explains such a boost in innovation. And she sees that for starters, it's not like everyone was waiting and declare and then started using the new molecules. It's not also that there was an anticipation effect. She really checks that. And she's also showing that it's not only the consumer demand, but really credible enforcement, the trade restrictions that has signaled to firms that they had to adapt. And also governments, I think, encouraging the development of those cleaner technologies. So she qualifies it as a low ambition but binding agreement that can trigger induced innovation. And it seems that it has really worked well in the case of the ozone layer. But again, this is quite specific to one type of molecule. And I think that the problem of climate change is much harder to solve. So that's more or less the conclusion. The implications for climate change of all what we discussed today are that we need to improve the benefit cost analysis. So we need to make the cost of abatement lower and the benefit of abatement higher. This can be done through the development of clean technologies, and that's what we are going to discuss next week when we talk about directed technological change. we need to understand the benefits and the perception from like the citizens and the policymaker perspective of the benefits as well. We need to lower our discount rate. So try, because if we discount the future a lot, of course, it's less, it makes the cost very salient and the benefits less so. So we need to encourage people to consider the intergenerational aspect and equity more seriously. And the last remark of this, lecture is that collective action theory, it explains weak climate cooperation, but at this stage of what we've seen, at least, it ignores domestic economic and political constraints. There's a whole area of research that works on that, but it's not what we've discussed today. Thank you so much for attending. I see you during the seminar. I will answer the questions that you have raised the best as I can during the seminars, but if you could send them to me by email so that I don't forget, it would be really amazing. Thank you. On Wednesday.